So in this lesson, we're going to focus on finding the surface area, lateral and surface area of cones and pyramids and spheres. Remember that area is, we want to paint the surface, or we want to wrap the surface in paper, or create the surface in paper. And so lateral, remember, is your lateral area is your lateral faces, and then your surface area is including the bases. So the lateral area of a cone is everything except for the circle. Lateral area for a cone is pi RL. Pi times the radius times L. L is the slant height. So if you take a cone, you have three measurements that are standard with a cone. You have the slant height, you have the height, and then you have the radius. So the height is how tall the cone stands up off the ground. The slant height is actually the length of the slant, how far it would be up the side of that cone, and then R is the radius. The surface area is that, so imagine that is like that white paper cup that you get a snow cone in, or a water cup sometimes. That's your lateral area. Your total surface area is what if it has a lid on it. So that includes the circle. So your surface area is your lateral area, right, the sides, plus the circle. And you have one circle for your cone. So find the lateral area and the surface area. So lateral area would be pi RL. Now, to process through this problem, you have to look and see what you have. So I have 30 is that slant, and I have R, which is 13. And so I can go ahead and I can do pi times R times L. If we leave it exact, then we would do 13 times 30. That gives me 390 pi. So I multiplied everything except for the pi, and that gives me my exact. Or I can get my approximate answer is 390 times pi and actually multiply it out, and I get 1,225.2, should I round to the nearest tenth. My surface area would be to take that previous lateral area, so 390 pi, and add the bottom circle, so pi R squared. So 390 plus 13 squared. Notice I'm doing everything except for pi. I'm not hitting the pi key. That is 559 pi, or 1756.2 rounded to the nearest tenth. Number 2, we work the same way. Only this time, pay attention to the information that you have. Always write the equation, y'all. If you will just be in the habit of, okay, lateral area is pi RL, and that formula is on the formula chart. You can just look it up. You don't have to remember it. Just go look it up. So then you just have to remember what the pieces are. R stands for the radius. Well, in this problem, I don't have the radius. I have the diameter. But I know that the radius is half of the diameter. And you get that L is the slant height, because that is on the slant, okay? And so it would be pi times R times L, 23.4. So 23.4 times 8. If I leave it exact, that would be 187.2 pi. That's what I get if I multiply 8 times 23.4, but don't do pi. And then if I go ahead and multiply that by pi, if I ask for the approximate answer or rounded to the nearest, then I get 588.1. Surface area would be to take that lateral area, 187.2. That's the benefit of leaving it exact, is you don't have to carry all those decimals out. So, and then you add the bottom circle, so that would be pi times 8 squared. So if I add 187.2 to 64, which is what 8 squared is, I get 251.2 pi, or 789.2 approximately. So number 3, same thing. Now we run into a problem with number 3. If you look, to do the lateral area, I need pi times R times L. So the problem is I have L, but I don't have R. But if you look back at the picture, look at what you do have. You do have 12, which is the height. Well, so we've got this little right triangle right here. We can go back to Pythagorean theorem to find anything we need, right triangles again. So if you remember your triples, then you'll know that that's a 5. If not, then you would do a squared, which would be, I call that r, right? R squared plus 12 squared is equal to 13 squared. If you go through the math, you get r squared is 25 or r is 5. Again, beneficial to know your triple. So it's pi times 5 times the slant height. Okay, that's L. This is H. H is your up and down height, right? Look for that little H that's right there in the picture. Times your slant height, pi r L. So 13 times 5 is 65. So it'd be 65 pi. If you don't multiply it out, you leave it exact in terms of pi. Or if I ask you to approximate and round to the nearest, then it would be approximately 204.2 to the nearest tenth, and that would be centimeters squared. Surface area would be to take that 65 pi, bring it down here, 65 pi RL, right? Pi RL plus pi r squared, because we add one circle to it. Pi r squared, we already found our r. So if I add 65 plus 25, I get 90. So my exact surface area would be 90 pi, and multiply that out to get my approximate. I would get 282.7 centimeters squared approximately. Okay? Now, for a pyramid. So pyramid has a different formula. The lateral area for a pyramid, we use S. I don't know why they use S. It doesn't matter. A lot of times I use LA just to keep up, right? Lateral area. So lateral area on your formula chart, it says S. So don't worry about that it says S. It's 1/2 PL. I like to say PL over 2. So PL over 2 is what I like to say, because I would rather divide by 2 than multiply by 1/2. So P stands for the perimeter of the base, and L stands for the slant height again. Now the surface area, so that gives you all of the triangles, okay? So your lateral area is your triangles. Your total surface area is all of your triangles on the sides plus your base, okay? So your total surface area is PL over 2 plus your base, where B stands for the area of the base. P stands for the perimeter of the base, which means you need to know what the base is. So if you look at number 1, the base is the shape that's not the triangles, because I have all triangles in my pyramids, and if I have a shape that's not a triangle, then that is going to be the base. I highly recommend that you highlight it. Okay, so I notice that the base is a square. So the base is a square, so the area of the square, I need P, I need L, and I need B to find the lateral and the total surface area. So I just go ahead and find it over to the side because I know I'm going to need it. So the area of the base would be 20 by 20. So the area of the base is 400. The perimeter of the base would be 20 plus 20 plus 20 plus 20. So the perimeter of the base will be 80. And then the slant height is 26, right? Here's your slant height right here. It's on the slanted surface. So now you can just plug everything into your formula. So lateral area is PL over 2, or 1/2 the perimeter of the base times the slant height. So that would be 80 times your slant height, which is 26, over 2. So 40 times 26 is 1,040. So the lateral area, or the 4 triangles in this shape, are 1,040. Y'all, if you get stuck, then you would find the base and the height of each triangle. So the base of the triangle is 20, the height of the triangle is 26. Base times height divided by 2, you find the area of that triangle, multiply it by 4. That's what the P and the L is doing. The P is taking care of the 4 triangles for you. Okay, surface area will be to add the square bottom. So I take that 1040 that I found, that's my 4 triangles, and I add your square base, which is 400. So my lateral area would be 1,440. My total surface area, excuse me. Now, the thing with pyramids is your base can change. Okay, always find your base first. So you've got all those triangles, and then in the middle of all those triangles, I have this pentagon. So I go, okay, well, to find the area of a pentagon, I need 1/2 the apothem times the perimeter. Well, you were given the apothem. So the apothem is 8.9. The perimeter would be, the side lengths are 13. So there are 5, because it's regular, there are 5 side lengths that are 13. So that is 65. So my perimeter of my base is 65, which then I already found the perimeter. So 65 times 8.9 divided by 2. Don't forget to divide by 2. The formula says to divide by 2 is 289.25. We already found P. That was 13 times 5, so that's 65. And then your slant height is 21.9. That was given. So you take your lateral area, the perimeter of the base, times the slant height, over 2, because the formula says so. So 65 times 21.9 divided by 2 is 711.75. Your surface area would be that lateral area, PL over 2, plus the area of one base, which we found to be 289.25. You get 1,001. So the total surface area is 1,001 units squared. Okay, number 3, find the area of the base. So I am going to use this triangle as the base, because I can see that the other ones come to that apex. So I'm going to take a break for a second. I'm going to focus on just the green triangle. The area of a triangle is base times height over 2. So the base of the triangle is 9. The height of the triangle is 7.8. And that's over 2 because it's a triangle. 9 times 7.8 divided by 2 is 35.1. Okay, the perimeter of the base, 9, 9, and 9. Okay, so the perimeter is then 9 times 3, which is 27. And then the slant height is 11.3. Always look for that slant. Okay, it's 11.3. So lateral area, perimeter times slant height over 2 is 152.55 centimeters squared. It came out nice to 0.55, so I'm not going to round it. We'll just leave it at 0.55. And then the surface area, you take that 152.55, you add the area of the base that we already found, 187.65. I like to do all of my math up front, and then all I have to do is use the formula. So I do everything with two-dimensional, my two-dimensional base, and then I go back and I use my three-dimensional formulas. Now 4 is going to be a little more complicated because if you look at the base is a hexagon. So in order to find the area of the hexagon, which that's my base, in order to find the area of the hexagon, I need 1/2 the apothem times the perimeter. Here's the problem. I have the side length, but I don't have the apothem. Okay, so let me redraw this so we can look at what we are used to seeing. Okay, so my side length was 6 all the way around. So that's easy. I know my perimeter then has to be 36. Okay, so in order to do this, think about what we need to do. We need our apothem. So draw in the apothem. Okay, so that's what I need. Well, what else do I know about this hexagon? Well, it's 6-sided, which means there are 6 triangles. Each of these angles has to be 60 degrees. I got to know something about the angles. I mean, there's no other way to know anything about the sides other than you might remember the radius. So that means this angle right here is 30. Well, I cut that side in half when I drew down the apothem. So that, if you look back at your 30, 60, 90 triangles, your short side's across from the 30, your long side is across from your 60, and that happens to be your apothem. So that's x root 3. So your apothem is 3 root 3. So I have 1/2 the apothem times the perimeter, which was 36. Okay, so the area of the base, and for right now, just so I don't have to write out a bunch of decimals, I'm going to multiply 1/2 times 3 times 36. So 18 times 3 is 54. Now, I'm just keeping the root 3 for now until I don't want to, I want to leave it exact. Okay, so just for right now, I'm going to leave it exact. Now, my lateral area, so now we've done everything. Oh, I need my slant height. I got my slant height, it's 12.2. So my lateral area is my perimeter times my slant height over 2 because the formula says so. So I multiply those together and I get 219.6. And that's inches squared. Then your surface area, you would take that 219.6 and you would add one base, that green. So if it asks you to leave it in exact form, you would leave it like that. But we can go ahead and switch it. If we want our approximate, we can add 54 times the square root of 3, and we get 313.1 inches squared. Okay, so you do have to remember that about finding your regular polygons. So remember to go with a hexagon's the easiest one because that uses your 30, 60, 90s. You got to remember those 30, 60, 90s. And then the last formula we're going to look at is the surface area of the sphere. There's only one surface on the sphere there's not a lateral area and a surface area, there's just one surface. So the formula for the surface area of a sphere, if you look at your formula chart, it says S is equal to 4 pi r squared. So it's basically 4 circles. So to find the area then, we would do 4 pi r squared. So to leave it exact, do 24 squared times 4. You get 2,304. So I multiplied everything except the pi. That's exact. And then I want the approximate. So I multiplied 2,304 times pi, and I get 7,238.2 meters squared. So that would be the approximate. So this is approximate. Remember, anytime you round, it's approximate. And then this is exact in terms of pi. So number 2, the only issue with number 2 is that I gave you the diameter instead of the radius. We always use the radius and everything, and if you'll write down the formula, you'll remember that, 4 pi r squared. The radius is 5, so it will be 4 times pi times radius squared. Well, to get the exact, I'm going to do 4 times 25. That's 100 pi. Don't multiply the pi out when you want to leave your answer exact or in terms of pi. And then if you want to approximate it, you would do 100 times pi, and that would give you 314, and that would be feet squared. Okay, so using these formulas is important. They are on your formula chart, so you need to know where they are. You need to be careful with your formulas for your area of your bases. Those are on the front of your formula chart. Their volume and surface area formulas are on the back. And then when you have circles, they give you the full equation instead of just putting it in terms of the base, because the base doesn't ever change when you have